Here, it passed by. So, you know, I work for Nearform, and you can see that we just rebranded. And so, you know, big applause for our rebrand. With a nice palette and blue color and so on. This is my first presentation with a new brand. I rushed to get the thing updated, so I hope everything is fine and you like it. I'm here to talk about a new way to profile Node.js. How many of you have deployed Node.js?
Yeah.
How many of you did not ever deploy Node.js in your life? I know, I knew that. Okay, so I don't know, it happened to me several times that I was called in the Sunday mornings or crazy moments where the maximum number of server was reached, and you know, angry people were angry, and my boss was on my back, and you know, wanted me out of the window really because I deployed this crazy thing called Node.js outside in there. I don't know. So the question that after we fixed the problem, and the question that we needed to ask ourselves after you fix the problem in production is why it is slow. Why is your system slow? What was the problem? What caused that production issue? What caused that performance issue? There is only one answer to that question, always. Okay? There's always one answer: bottlenecks. So there is one bottleneck that is causing your application to slow down. Only one, all the time. It's very easy. No, probably not, or maybe yes. Who knows? We'll see. So bottleneck is the key part of this presentation, and how to find the bottleneck in your system. If your application has a performance problem, it is because you know there is a bottleneck, and it stops it's actually slowing your application down, and your data cannot flow fast enough. You know, this nice deer type of thing. You can have two types of bottlenecks in your application. You can have internal bottleneck, which means that your Node.js process is on fire. I've done a nice presentation about this. And then if the bottleneck is external, it's something else is on fire. Typically my database is always database guy fault, you know. So that's what it is. And so that is the basics, the balance between our two things. Now, the question now is, where is the bottleneck? You need to ask this, because you know we have decided there are two types of bottleneck. There is always one bottleneck. Two types of bottleneck. Where is the bottleneck? What is slowing my application down? That was the basic question. Why is it slow? Now we have turned this in where is the bottleneck? This is a nice journey of finding a bottleneck. And you know, you start your little turtle there. That's my Node.js application, which has a performance issue. And you start, and you have a problems in production. And oh, I don't know, this thing is low. So what I need to look for is, I set up some diagnostics to gather some data on what it was doing, because you know, and the people are angry and I need to figure it out. So with this diagnostic in place, I can gather some data which is typically coarse-grained and polluted as well. You know, I have 10,000 users calling my system, my shopping cart thing. At the same time, maybe I have one little bug somewhere that causes a performance problem that causes the whole system to go down. I don't know. How can I find it? Like, how can I define the specific thing? So the key part here is reproducing the problem. You need to reproduce the problem on your staging environment or your non-production environment. So you need to move from detecting your problem in production to a lab where you can hit a button and reproduce the problem. Because if you don't do this, if you cannot reproduce the problem artificially, you will never know that you have fixed it. So there's no point in doing any work until you can reproduce the problem. So you need to spend time, and I've done this several times, to actually reproduce the problem on my machine. And first of all, I reproduce it on the cloud because typically there are a lot of other things involved and it's way harder to reproduce it on my development box, but that's the ultimate goal. So once I reproduce the problem on the cloud, then I can gather a little bit more diagnostic data, and finally I can run it on my machine. That is the key part. You need to, if you coding on servers when they are running on Kubernetes cluster inside Docker containers, or maybe you're doing serverless, it's impossible. It's very, very hard. So what you need to do is you need to code it on your machine, reproduce it on your machine, so you can code. So after you've done that step, now you can tap into some more data. So the tool that you use typically for diagnostics on servers is called APM, Application Performance Monitoring Solution. You can, there's a huge amount of vendors. They're all friends, not making any favorites. Pick one, use one. Some of them are better than others though. So, whatever. So what you do is, once you are on your machine, you can tap into some more data. You can tap into some more details from Node.js, from V8, data that is way harder to gather in production. You might ask why. Because it costs more. So all those diagnostic tools add some overhead in your application. One of those vendors, so there's a nice vendor that has a nice 20% overhead, and then another vendor that has 100% overhead. So basically, once you run the IP and the instrumentation, you actually have to double the number of servers to serve the same users. Probably not something that you want, so do your measurements when you pick a vendor for that stuff. There is a nice one that gets only 20%, so, which is nice. And then, but again, those things, extracting this, the more data you extract from a running node process, the more that process slows down. So there is a point of no return where you can gather all the data that you might need. So in development instead, or in artificial environment, you can actually extract all the data that you want. You can slow your process down to a crawl if you need to extract the data that you need. So that's the goal. After that, you need to fix the problem. How do you fix the problem? Well, I used to walk my dog. I walk my dog. Take the dog, go for a walk, and think about the problem. I don't know. Yeah. And then you get a performance application. So, we have written the first two. So, this presentation is about the tools that we have written to improve this. The first one of this tool is this thing called AutoCannon. It's a tool that is used to generate load on your server. It's written in JavaScript, and you can script it with JavaScript as well, so you can actually get a little bit scenarios and stuff on top. It's very straightforward to use. Skip this slide. This is the other tool that we have built, which is Node Clinic. And Node Clinic helps out when you are on your development machine. Now, Node Clinic is a suite of tools, and we have three tools. So I was there presenting. There was one tool, then we have three tools. And the first one is that I'm talking about Doctor Calista some heuristics, inject some probes in your node process, extract some assets out with some heuristics, and create some recommendations. How can you create recommendation? We have put some AI. So there's TensorFlow running in there, and some data science and math and stuff like that. It's very hard. I can't really read that code, you can have a look. I didn't write it, so that's I can say. But it's only there, it's based on data science. And this is what it generates. This is the type of thing it generates. So it detects a potential I/O issue. You can see a lot of graphing. We track CPU usage, memory usage, the number of handles. These are the sockets that are open in the system. 5 sockets that are open, and you can see here that this is the average delay. And you see we detect a potential I/O issue. Why? Because we have big spikes interleaved and not much as activity. So basically there is something happening from time to time because of a big chunk of a spike of CPU activity, but a long wait between these things. Clinic Flame is a tool to So Clean collects some metrics by sampling the CPU. So basically what it does is, your process is running, it takes a sample, and then after some time it takes another sample. What samples that? Your stack. Function, call, function, call, function, call, function, call, function, blah, blah, blah. We take all of that and we save it, and we save all those samples. And after we have saved all those samples, we just sum it all up and generate a visualization. And this is what it looks like. We are doing a big we are changing the UI of this. We are doing a new UI design which will look way better in a while. You can see that there is a function at the top of the stack, and that's your bottleneck. And this is the new thing that we have launched in July, which is called bottleneck, probably the start of this presentation. It collects metrics by using async hooks. I don't know if you've ever heard about async hooks. It's a new diagnostic feature in Node, from Node 8.5, it was usable, something like that. And it tracks latency, and you can use this to track latency between operations. So you can track, this operation starts now, and these are your operations starts now, and you finish after 5 milliseconds, 10 milliseconds, 1 second, whatever. And I can track for all of these things. Now this produces a huge amount of data. So the problem of this is generating a visualization that can easily represent the data and making that data easily discoverable. And you can detect if you have seen any problems. This is what bottleneck look like. I will do a demo, so I will dig deep at that point. The question now is, we move from, why it is low to where is the bottleneck. Now we know we can ask the doctor, where is the bottleneck? And the doctor can actually, does recommend two things. Can recommend clinic flame for internal bottlenecks and clinic bottleneck for external bottleneck. Why? Because bottleneck enables us to track I/O operation. So if it's something that is slowing down my application because there's a huge latency in my database query or in my file system, bottleneck will visualize that. So, and you can do this flow. So now is the time for the live demo. And if you want, you can play along with this link, nf.interact.ie/interact. You can play with this, however, not from your phone. These are UI built for the desktop, so if you can, they work on the phone, they load, but they're not really touch friendly. So you might have some trouble playing with the thing. So let's see okay. I have a nice server called One, and I can call with him. And you can see it takes a while, and you can see this not really fast. What is this return? Well, I don't know, but I built it. No, yeah, I did it. So let's see. We can use autocannon to see how this performs. So they told me it's slow. So we are running this syntax here, which is the new. We released this in the autocannon 3 last week or something. So we get some data out. And you can see that the median from the number of requests per second is 2 requests per second here. Oh, do you think that 2 requests per second is fast or slow? I don't know. Let's try with, instead of 2 connections, let's try with 100 and see what that is. We are just using 2 connections, so not even complete. Okay, interesting. Maybe we have a problem, right? So what we do clinic, doctor, and we use a similar syntax, and here we go. Oh, not one. So doctor, it's giving a couple of warnings, but whatever, don't care about that. And it's actually executing our thing, it executes our autocannon, then it analyzes the data, and it uploads something. So it opens up something, and you can see that it detects, let me zoom in, it detects a potential I/O issue. You can see those big spikes, okay? Now, the best part about Doctor is that it has this nice recommendation panel. So it shows what to do next. And it says, you know, there might be some long-running asynchronous activity. This means that the bottleneck is not the node process at all, but rather an I/O application, operation. There is also read more that explains a little bit how the event loop work and stuff like that. It tells you what to do next, which is use clean bottleneck, and it explains how to visualize the stuff and how to do other things. So you can check it out. The docs is really useful. So yeah, it should tell me to use bottleneck. So what I do is I go here and just clean bottleneck. Live performance measurement on a stage with a MacBook Pro, with a MacBook, what can go wrong? So this is bottleneck. I hope you can see that well from the back. Can you see this well from the back? Maybe big enough? Yeah, I hope the color should work. Can you read the stuff from the back? Yeah, okay, perfect. So you can see a bunch of stuff here. So first of all, you have this nice diagram here, but you have a legenda here that shows the number of asynchronous operations happening anytime. And you can see here that you have a lot of different stuff. There is networks, there is scheduling, and there is other. Let's talk about other in a second. So network is the sockets, and scheduling is promises and next ticks and stuff like that. And other is custom libraries that are being instrumented with async hooks. So you need, in order to get very extremely good data out of async hooks, you need to actually use libraries that have been instrumented. Some of them are instrumented, some of them not. This application is built on MongoDB, and the MongoDB library client is not instrumented, but we are using Mongo.js, which is a very thin wrapper around MongoDB. So, given that we know that we're using Node.js, I'm actually focusing on what is happening here. So, this is where application starts, and this is basically the start of my app, really doing nothing. But there is the next big first thing is this specific block, and we are using this web framework of Fastify. But this is basically a node core diagram, a node core part of it. It starts from Fastify, but this asynchronous operation is node core. And you can see we are basically spending a lot of time waiting for a connection that comes in. So might be that my service is kind of idle a little bit. But it is an interesting part. We are in two big branches that is waiting from Mongo.js and MongoDB. Now let's focus on Mongo.js because it's perhaps MongoDB, so it's more interesting for us. And you can see that it's divided into two trunks, the first one and the second one. Now, if we click on one, we can actually see the exact stack trace of which this asynchronous operation was started. And you can see that you have a nice line here, at object 1.js colon 11. This is where this asynchronous operation was started. Now, if you note that this number 3.2 is that of the overall time my application is waiting for that query to happen during my measurement time. So my whole application is waiting for that specific query to finish 3.2 seconds over my 5 seconds of run of my benchmark. So it means, oh, this might be the problem, right? This is slow. This query takes a long time. My application is always waiting for this to happen. And then there is the second one, and this second one is, again, it's on like 13. So let's open up my file, because it doesn't look like, I don't know. What are we doing? Line 11? Oh, it's appeared to Mongo. So we are finding all things in a collection, sorting them, and taking 5. And we're taking the last one and first one. This is a sample out of MongoDB, so out of NPM. So maybe we can actually see what MongoDB thinks about this query. So what I do, I just copy this for practice, for simplification. So I just do Mongo, use NPM. And then I have DB modules. This is my query, and you can see it takes a little bit of time to reply. So we can do what we can do. We can call this function called explain, which will show us how MongoDB executes that query. And what it's doing actually a sort of the full collection. It's going to take a while to do that, right? It's not simple. So maybe there is something else we can use. There is another collection here called module index, which, guess what you do? So we can actually use the same thing and check, and modules index, in fact, as an index on what you are using, and it's actually using that index to execute the query. So it will actually, we expect this to be fast, at least, or faster than before. So you can see this is actually, you can perceive that this is actually extremely fast. So now it's time to validate if our assumption is right. So what we do, we move to, we change the collection to module index, and we see if this has improved things. So we do the same thing that we did before with two connection, and we see how it goes, how it works. So hey, it's running, it's ticking. And now it's doing 94, over here you can see, 94 requests per second with two concurrent connection, which is simply pretty good improvement for, a tiny fix. However, I'm not really satisfied. Like, can it go faster? Maybe, yes. So let's try. Maybe it's limited because it can just do 94 because we have 100 concurrent connection, right? So maybe it's that, we have two concurrent connections, so that's why. So let's increase and see how it reacts to more load. Now, you can see that it does not really increasing. You can see this go to 94 to 96, but what it happened, my latency exploded. So you can see that the latency at 99 of 99% is 1 second, more than 1 second. So this is a problem. Right? We can't ship this. This is not good enough for us. Okay, this latency for 100 concurrent requests is way too high. So what we do next is we can use Doctor again to see what is the problem here. So again, we keep using Doctor, and we ask the Doctor what to do. So we run this with same tools that we did before. We just use a new thing, and we check what is the problem. Now, you can see now the Doctor detects something different, which is an event loop delay problem. I hope all of you are familiar with the concept of an event loop, loop blocking. What is happening is, you know that Node.js executes things synchronously, one event at a time, one asynchronous event at a time. And if the time that's taking for the execution of that single event gets too big, it takes too much time, you will have a long pile of events queuing up, and you will cause your event loop to block. So this is a big problem, and this is what is causing this. We can have the event loop can block up to significantly block up to half a second, which means it's not receiving any I/O event for half a second. It's a big problem. Okay. So what it does, what it recommends, we open up our magic panel and tell us to use clinic flame. So what we do here, we do the same thing we did before. We swap it and we use clinic flame. Which we have already seen this. This is basically our uploads our Flanger tool, and here we go. So in here, let me zoom in. Okay, and one over. So what you can see here that we have a function called ComputeMagic that is taking all the time. And we are computing magic, right? How can we compute magic? We compute magic. So, it's at this line, so it's file2.js line 25. So what we do is we open 2.js and we go at line 25. And here is the thing, and this is my function. Guess who coded this? I don't know. From time to time, developer codes strange things in their application. So somebody just put this in. You can look for the Git history of this and find out who, but I don't know. So we can actually remove the stuff because it was just completely useless piece of code. This typically happens in a lot of enterprise systems. Okay, there is from time to time there is code added over time. Team members comes in, gets out, and certain area of the code that we're using in a certain way, now they're using it in a completely different way, and those are now causing a performance problem. So it can happen all the time. And it might just be a for loop with 10,000 elements that you have somewhere lurking in there for whatever reason. And that was fine when it was written, but now it's not really fine anymore. So we can remove that. And you can see now so at this point, we can actually run it again against without a canon and see how it looks like, how it works. And now it's a very better 1,200 requests per second, which is way nicer than it was before. And you can actually see that the latency from 1,000, from a second and a half went down to a nice 222 milliseconds, which is way better than it was before. And so we can ship this. You might want to check again and see what the value 2 says. So you can actually check, for example, you can check with doctor to confirm that we cannot really, maybe we can improve this again, right? I don't know. Do you think we can improve this again?
Yes.
Yeah. You could have looked at the time, and you might have thought that almost the time is finished, so probably no. But you can actually use the values tool, and you can play with. We can also check with bottleneck to see how our query are going, and so on, and see how the things are working out. Now you can see that between the number of requests per second with bottleneck got reduced by 10 times. Because we are extracting 30-second, 1 minute run with bottleneck will probably generate 500 megabytes of data. Be prepared. We are extracting a lot of information. And now you can see that things are way different now, and there is you actually see that these queries are there's a lot more asynchronous activities happening over here, and you can see that the query is still super hard because there's still a lot of things happening. But you can see from here that the number of async operations on the right has grown up significantly. So those things are still problematic, but they are actually, there's a lot more happening. And you can see that now all of those things are coming out. So there is also some activity into the MongoDB driver itself that might be worthy of looking at. If you see this lot of scheduling stuff in here, you're having your application make do work. And this is coming from the MongoDB client. So I would like to do. Why is not? Yeah. Okay. So this was not me. I didn't build this. Okay. No, sorry. It was done by the Nearform team, and I don't kill anybody. It was done by a lot of people at Nearform. Andreas, our data scientist, Joy, the initial designer, Connor, our chief product officer, me, and probably the product manager of this thing at this point, Matthias Boos, our match science in charge, and Alan that did all the UX of bottleneck. So if you see those magical animation, is all him. Camille, our full stack developer, and David McClemens that did the UX. So I want to say a couple of parting words. How much time do I still have? Do we have more time? 5 minutes?
Yeah, you 5 minutes. I'll give you that.
5 minutes. So first of all, set quantifiable performance goals all the time. Your application, so it's very important that when you start embarking to a performance optimization journey, you need to decide what's your goal and what's your exit criteria. You can optimize, you can say, I'll make this as fast as possible. Because you can make something that's always faster. There's no end to it. You can write it in assembly, right? So you need to specify when it's fast enough. You need to specify what's your exit criteria. What do I want to do at the top? Okay? So set a goal, this is your exit criteria, and move on. When you reach it, yeah, done, fast enough. Another way to write code that does not have performance problem in production is to use fast libraries. So if you're using, some of the libraries that you can find in NPM have no have different performance profiles, and there are not really too many independent benchmarks that measure the various things, so you might want to do some investigation when using stuff and looking at. So I want to talk about Pinot. It's the fastest logger for Node.js, and it's extremely fast, and it creates a zero overhead logging. I did a nice talk some time ago about the cost of logging. Check it out, and with David McClements. And I also wrote. I started Fastify. And now it's a community. It's a web framework, but it's more a community than a web framework actually. It has, it's been growing. There are 10 collaborators, people working on the thing. We have one in the room, so hey, hi. And here it is. It's a high-speed web framework. But anyway, use whatever you want to use. Just be certain that the performance profile of what you're using is compatible to the non-functional requirements of your application. Because you can't really, otherwise you will be dissatisfied. That is where the problem is. Because, as JavaScript developer and Node developers, we are focusing most of the time in pushing features out of the door as fast as we can. We want the best developer tools, we want to produce new features and build our application in a very fast way. We have those product managers that are bottleneck. When is this going to be done? However, from time to time, it might be worth considering that the last 20% is the hardest part. And you need to take into account that if there are specific non-functional requirements for your application, you need to start thinking about those early on in the design of your system, not at the latest one. It has been, and I get some nice stories. Oh, it was brilliantly on my machine, or it was brilliantly on the development environment. Then going to the users and I've seen a bundle sent to a browser of 15 megabytes. 15 megabytes of JavaScript shipped to the browser, and it was just like, really? Anyway, so you need always to balance the things. Okay, so you don't want to go and write assembly, but you might also want to check that what you are writing is going to be fast enough. So start load testing and start doing benchmarking early on in your development cycle. Remember that you don't have to go ludicrous speed. So you don't need to write the fastest thing ever. You don't have to write the best thing, the best API. You don't have to do the greatest thing. You can, it's not needed, okay? You can be fast enough. It's fine to be slow. Super fine to be slow, okay? Let's write those things and optimize them when they are needed. So, talk to us. There is a nice form here if you want to fill it, provide some feedbacks about the tools. The Node Clinic initiative is something that we are promoting at Nearform to improve how people solve performance problems in the Node.js area. There were not so many developer tools that were freely available, so that's why we developed this thing. Again, I work for Nearform. You probably know us, so at this point I don't know if I need to say anything. But it's if you need help with Node.js with performance, come talk to us, tweet to me, and so on and so forth. And I don't know. I think I'm done, and thank you.